Hello! Be welcome for a new episode involving the lab color space in Photoshop. Now we are going to take a comparative look between using Hue Saturation effect in RGB versus lab color modes. You'll see here the differences and how can they be creatively exploited. See here a 16-bit RGB image. Now we duplicate it, convert the copy to lab mode and apply to each image a Hue Saturation adjustment layer. Let's compare the results of the Hue Saturation effect applied to both RGB and lab versions. As can be seen, as desaturation advances, the differences between these two images are gradually accentuated. Finally, the desaturated RGB image shows distortions and low contrast. On the other hand, in lab mode, especially at high saturation values, the effect exacerbates, leading to undesirable results. To understand why and how all the above are so, let's take a look behind the scene where the math acts. I will not expose here in deep this math. It's more practical to understand how it works and see the results. This 5-color image in RGB and lab versions with Hue Saturation adjustment layer applied will help us to do it. On each unicolor rectangle are placed 2 sample points to visualize in info panel the color representation in RGB respectively lab versus HSB. Why do we need this? In the Hue Saturation panel, the only function of the saturation slider is to change the colors of an image. In fact, its position does not represent the saturation of color. Saturation or chroma, defined as the purity of the color, can be described via HSB color model. The HSB model allows us to select the color on the base of the 3 fundamental characteristics, hue, saturation and brightness, in a more intuitive way as the human eye perceives. Although the HSB model can be used in Photoshop to define a color, you cannot use it to create or edit images. For this are used RGB or lab color modes. So presenting here the colors in RGB or lab versus HSB, one can better understand how the Hue Saturation effect works in both color spaces. In RGB mode, the adjustments via saturation slider in Hue Saturation panel is based on the average of max and min values of the color components. Max and min are the largest and respectively the lowest value, whichever of the red, green or blue are these. When the saturation slider moves, the max and min changes, but the average value is kept constant in any position of the scale. As the slider moves from 0 to the left, the color components are adjusted proportionally to get the same level at the left end of the scale for the complete desaturation. What happens when the slider moves from 0 to the right to intensify saturation? You can watch here how the color components are gradually adjusted. Max value increases and min decreases, keeping unchanged the average. The intermediate RGB value increases if it is above the average of max and min and decreases if it is below. The relative RGB adjustment rates are calculated to preserve the color tone represented by hue value. In HSB, saturation represents the amount of gray in proportion to the color, measured as a percentage from 0, gray, to 100, fully saturated. In RGB, this means that a color is fully saturated when 1 or 2 of the RGB components have 0 value. Brightness is the relative lightness or darkness of the color, measured in HSB as a percentage from 0 black to 100 white and is proportional with RGB max value. 100% brightness means 255 max value. As a result, when working in RGB, the saturation cannot be increased as long as the brightness is 100%. Let's watch what happens next as the slider continues moving. Fully saturated from the start, the red remains permanently unchanged. The yellow keeps unchanged also, even if it is only 75% saturated. That's because the initial brightness is 100%. The green gets full saturation when the slider is at 34. From now on it will not be altered. When the slider is at 58, the blue is saturated 87% only. The brightness is 100%. No changes will happen from now on. At the slider position 67, the last color gets the full saturation. From here to the end of the scale, nothing happens anymore. As you can see, all colors keep their chromatic tone, hue, unchanged. But because the saturation adjustment considers only max and min values and the third RGB component is always ignored, the luminosity is not preserved. Now let's adjust saturation of the same 5-color image in lab color mode. In lab mode, when adjusting the saturation, the luminosity is preserved. The value L does not change regardless of the slider position. As the slider moves from 0 to the left, the values A and B color components are gradually reduced to 0 to get the full desaturation at the left end of the scale. As the slider moves from 0 to the right, each color component is pushed to its extreme value, to -128 if starts from a negative value, or to 127 if starts from a positive one. Each color is altered until at least one of its components reaches the extreme value, -128 or 127, even if full saturation or maximum brightness has already been reached. That's possible because the hue is not preserved when you adjust saturation in lab mode. Once a color has reached an extreme value, it becomes insensitive to the further advance of the slider. In this case, from the position 76 to the end of the scale, the entire image is not affected anymore. For a better understanding, let's take a comparative look to how the hue saturation effect works in RGB versus lab color modes. See here a color wheel I've built for this purpose. On the external ring are placed the 12 primary, secondary and tertiary RGB colors. Watch in info panel the RGB versus HSB values for each unicolor sector of the wheel. On each spoke of the wheel, the hue and brightness values are kept constant. Saturation decreases by 25% for each ring inward. On each ring of the wheel, all sectors keep the same average of the maximum and minimum values of the RGB components. Let's make a copy, convert it to lab mode and apply to both images a hue saturation adjustment layer. Now let's compare the result of the hue saturation effect applied to RGB and lab versions of the color wheel. Start desaturating. As the saturation slider moves from 0 to the left, the differences between RGB and lab images accentuate. In the end, these images look totally different, although at the start were identical. In RGB mode, desaturation pushes the color to a gray level identical with the average of the maximum and minimum values of the components. As you saw, this average value is identical for all sectors in a ring. So when desaturation completes, each ring gets the same gray color. In lab mode, the luminosity of each color is preserved and all sectors of the wheel remain distinct. When the saturation slider moves from 0 to 100, the RGB image remains unchanged. Don't be surprised. That does not mean the hue saturation effect cannot affect RGB images. Here, that's because all the colors in this wheel are fully saturated or have maximum brightness. As I pointed out before, all such RGB colors are insensitive when moving the saturation slider along the positive side of the scale. Therefore, when you try to increase the saturation of an RGB image, even a complex one, many pixels remain unaffected. On the contrary, the lab image changes drastically. Here each pixel can be modified until one or both color components reach the extreme value, -128 or 127. So as the slider moves to the right, more and more pixels get a pure color. The number of identical pixels increases and the image can lose details. That's why the hue saturation effect works more aggressively in lab mode than in RGB. Let's summarize. When you set the saturation of an RGB image using the hue saturation adjustment, luminosity is not preserved, hue remains unaltered. Consequences. When you desaturate, the number of identical pixels increases, the contrast is diminished, and the image may lose details. On the contrary, when saturation increases, many pixels remain unaffected. The alteration of the image is moderate. In lab mode, you'll find the opposite situation: luminosity preserved, hue affected. Consequences. When desaturate, pixels remain well defined and the image keeps the contrast. When saturation increases, many pixels get the same color. The image can lose details. Even distortions may appear. It seems logical to conclude that the best way to use the hue saturation adjustment is working in lab mode to desaturate and in RGB to increase saturation. In many situations that's true, but this is not an absolute rule. So whenever you need to use this effect, take a little time and try both ways. I hope that the knowledge included in this tutorial will help you to make always the right choice for the best result. That's all for today's episode. I hope it is useful for you. If you liked it, click the like button and share this video with your friends. Please subscribe to this channel if you haven't already. Ring the bell to get notified about the future episodes. If you have any comments and questions, leave them in the section below. I will be glad to answer promptly.